Okay, so here's a question that was asked over email. We're asked to factor this completely, and it's a trinomial. And the first thing you always want to look for when you're factoring is greatest common factor. And there isn't one in this problem, so we would just go straight down to factoring a trinomial. And in this instance, I'm just going to use trial and error. The way that we're going to deal with this y to the fourth right here, and that's a 4, is we're going to split it up, and we're going to put a y squared here and a y squared there. And what that will allow us to do is that when I do the outside-inside portion of FOIL, it will actually take care of the y squared that we need right there. See, normally we're used to looking at, problems like this, where we have a squared here and a first power here and then a constant. And this is basically the same format, except we have twice a squared here. So we have a squared squared, and then we have a squared here. So it's this situation, just each of these are amplified by 2. Okay, so normally in this scenario, you would put a y and a y here to take care of the y squared. Here we're going to put y squared and y squared. Okay, and then I'm going to use for 49 a 49 and 1. And if I take a look at the outside portion of FOIL, that would give me 49y squared, and the inside portion of FOIL would give me a 1y squared. So if I put a negative sign in front of each of these, that would add to give me a negative 50, which is what I need for the middle, and then I need to check the last. If I take negative times negative, I do get a positive, so that works there. So this factors into y squared minus 1 and y squared minus 49. Okay, now we're not done because of the fact that if you look at this, if you look at each of these factors separately, these actually both still factor. You can see the y squared minus 1 is a difference of squares, and so is the y squared minus 49. So I can write y squared minus 1 as y squared minus 1 squared, and y squared minus 49 can be written as y squared minus 7 squared. Okay, so our difference of squares formula says this. It says, let's see if I have enough room here, a squared minus b squared factors into a minus b times a plus b. Okay, so what I'm trying to do is fit it into that form. And I've got it in that form. I can see here that my a is comparable to my y. My b is comparable to my 1 for this particular piece. For this piece, my a is comparable to my y, and my b is comparable to my 7. Okay, so if I take each of these pieces, plug them into the formula, then this will be fully factored. Okay, so y squared minus 1 is going to factor into y minus 1 and y plus 1. And that's using my difference of squares. And then y squared minus 49 will factor into y minus 7 and y plus 7. So this is actually your answer that is fully factored.